Assalamu alaikum my dear students, how are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEBS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 10 students. My dear students, our today's topic chapter 10 discussion or today's lecture number 3 and HW number 2. My dear students, let's start our class. This is chapter 10, static electricity. In our previous class we have already done 4 mathematical problem. Today we will discuss about first of all electric field. So first, what is electric field? This is a knowledge based question. The definition will be the region with which a charged particle experiences electric force is called electric field. I repeat, electric field means the region with which a charged particle experiences electric force is called electric field. In the electric field indicated by capital E. My dear students, electric field indicated by capital E, and we know the formula E equals to K Q divided by R square. E equals to K Q divided by R square. This is the formula of electric field. Electric field means the region within which a charged particle experiences electric force is called electric field, and E equals to K Q divided by R square. Here Q is charge and R is distance and K is a constant. The value of this constant K equals to 9 into 10 to the power 9. K equals to 9 into 10 to the power 9 Newton meter square per coulomb square. Newton meter per coulomb square. My dear students, now come to, if any charge Q is brought in this electric field, then it will feel F force, and on F force on it, and the magnitude of F will be F equals to QE. F equals to QE. Here F will be force, Q charge, and E means electric field. I repeat, if any charge Q is brought in this electric field, then it will feel the F force on it, and the magnitude of F will be F equals to QE. So my dear students, these two formula you have to memorize for mathematical question, for mathematical problem. As force F is a vector and Q charge is a scalar. Here force F is vector quantity and charge Q is scalar quantity. My dear students, this is very important MCQ. So electric field E itself is a vector. Okay, electric field E is a vector and its unit is Newton per coulomb. Newton per coulomb. My dear students, now see, to make it easy, electric field cannot be seen, but to make it easy to understand, sometimes one type of completely imaginary lines are drawn, and that is called electric lines of force, and which is introduced by scientist Michael Faraday. Our known world is three-dimensional. So the lines of force will spread in all the direction, and to show these are drawn in a plane. Here see the picture, here the positive charge and here is negative charge. So lines of force, this is the lines of force. Okay, this is the lines of force. Lines of force diverges from positive charge. See, everyone see, here is a positive charge. This is the lines of force. Okay, these lines spread everywhere. This is the lines of force diverges from positive charge. From positive charge, lines of force diverges, and for negative charge, the lines of force converges. Okay, this way, in this way, the direction will be here. For negative charge, the direction will be here, and for positive charge, the direction will be the outside. Okay, my dear students, I repeat, the lines of force diverges from positive charge, and the lines of force converges into negative charge. Now there are some rules of drawing lines of force. Rules number 1, in case of positive charge, the lines of force emerge from positive charges, and in case of negative charge, the lines of force converges into negative charges that we have already discussed. And in a specific point, the direction of lines of force is the direction of the electric field. Now number B, the more the amount of charge, the more the number of lines of force. Number C, the nearer of the lines of force, the more the magnitude of electric field. And number D, the lines of force of one charge never intercept the lines of force of another charges. That is we have shown in this figure. And in next figure number A, that is in this figure, the lines of force of two opposite charges are shown. Here this is minus charge, negative charge, and this is positive charge. So we can see the lines of force of one charge ended up with another charge. See, from here these lines started, it will go to the negative charges. Okay, so the lines of force of one charge ended up the another charges, and where the magnitude of electric field is higher, the number of lines of force is higher. Okay, here the magnitude of electric field is higher, so the lines of force also higher. Okay, and when the figure is we see in the figure, it gives a feeling that the two charges are attracting one another. These two charges are attracting one another because they are opposite charge. Here is minus charge and here is positive charge, so they are attracting each other. Now in figure 2, we can see that here the same charge, here positive charge, here also positive charge. So these two charges are repel each other. Okay, that's why here the electric field is lower and the lines of force also less than this than this one. Okay, and in the middle portion, here electric field is 0, here is E equals to 0, that's why here is vacant. Okay, my dear students, now come to next topic, mathematical. Now we will solve a mathematical problem. See here, question number 1, what is the magnitude of the electric field at a distance of 10 meter for 5 coulomb charge? My dear students, now we have right here given the for 5 coulomb charge, here charge Q1 equals to 5 coulomb, the Q2 charge we know the charge of electron is minus 1.6 into 10 to the power minus 19 coulomb. Here given the distance between these two charges, that is r given 10 meter, and we have to find out the magnitude of electric field, that is E equals to what? My dear students, from the above from the formula of electric field, we know that the formula E equals to Q divided by R square, that we have already discussed. Okay, now K, we know the magnitude of K is 9 into 10 to the power 9 Newton meter square per coulomb square. Okay, now put the value 9 into 10 to the power 9 into Q means 5 into minus 1.6 into 10 to the power minus 19 coulomb divided by R square. R means 10 whole square. So my dear students, now do the calculation. It will be 4.5, sorry, it will be Q. So here only we put the value of Q, that is 5, that is 5 coulomb. So it will be, by doing this calculation, 4.5 into 10 to the power 8 Newton per coulomb. Okay, the electric field, the value of electric field will be 4.5 into 10 to the power 8 Newton per coulomb. My dear students, now come to next mathematical problem. Now we will solve the next mathematical problem. Here given the question, a charge of 3 coulomb is experiencing a force of 10 Newton. What is the electric field? Now here write given charge Q equals to 3 coulomb. Here given the force F equals to 10 Newton. And what is the electric field? That is E equals to what? My dear students, we have learned another formula here. F equals to QE. F equals to QE. So from this equation we can write E equals to F divided by Q. So F, the value of F is 10 Newton and the value of Q is 3 coulomb. So it will be 10 divided by 3, it will be 3.33 Newton per coulomb. This is the answer. Okay, the unit of electric field is Newton per coulomb. My dear students, I hope all of you have understood these two mathematical problems. Now come to next topic, electric potential. My dear students, this is another important knowledge based question. What is electric potential? First of all, heat will flow from the material with higher temperature to the material with lower temperature. My dear students, this is the basic information. We know that heat flow from the material with the higher temperature to the material with the lower temperature. Heat can even flow from a material with high temperature and less heat to a material with more heat. And when we discuss the static electricity, we said several times that if we accumulate charge in a material and if it touches another material, then charge will flow into the second material. And if the amount of heat and temperature, so if two materials have different amount of charges inside and if contact is made between them, then charge will flow to the material with the lower potential from with the higher potential. So my dear students, the definition will like this will be like this. The electric potential means the work done to bring a unit positive charge from an infinite distance to any point of the electric field is called the electric potential of that point. I repeat, the electric potential means the work done to bring a unit positive charge from an infinite distance to any point of the electric field is called electric potential of that point. And the if the radius of the metallic sphere that is the charge, if the charge is Q, then the potential V will be V equals to Q divided by C. Here Q is charge and C is capacitance. Okay. Now we know the another value of C equals to R divided by K. C equals to R divided by K. So from this equation we can write V equals to Q divided by C, and we know C equals to R divided by K. So it will be V equals to, we put the value, if we put the value here, so Q divided by R divided by K, so we can write V equals to K into Q divided by R. This is also a formula, my dear students, and we know that the value of K is 9 into 10 to the power 9 Newton meter square per coulomb square. Okay, so and we know the unit of potential is volt. The unit of potential will be volt. My dear students, now come to here. In the presence of charge in a sphere, the electric field is E is created around it, and so the charges Q is brought to it. The charge will experience a force, and that is we have already learned that F equals to EQ. F equals to EQ, and you have to memorize also this formula. Potential is the amount of work done to move one unit charge and somewhere, and if there is no charge around, then there is no electric field. And the charge will not experience any force. So that means no work will have to be done to bring a unit charge. So we will say that there is no potential. But if there is any charge around, some work has to be done to bring the unit of charge, and the amount of work done is potential, that we have already learnt here. This is the definition of electric potential. If the W is W amount of work done to bring a charge, then we can write the electric potential like this: V equals to W divided by Q. My dear students, this is the another important formula. So for doing the mathematical problem, we have to memorize this one formula, and this one. V equals to W divided by Q. Here V is electric potential, W is work done, and Q is charge. My dear students, now your SW, today's SW number 2 and mathematical problem number 1 and 2. So this one is mathematical number 1 and 2 is your SW, and submit it on Saturday. My dear students, I hope all of you have understood our today's topic. Practice properly at home this topic. See you again in the next class. Allah Hafiz.